Far beneath the surface of the Atlantic Ocean, where golden sunlight gradually fades into eternal darkness, lies a region that has captured human imagination for countless generations. The Bermuda Triangle stretches across vast waters, its invisible boundaries connecting three distant shores: the bustling coastal city of Miami, the remote coral island of Bermuda, and the lush tropical coast of Puerto Rico. Within this triangle of endless ocean, stories have been born that seem to defy all earthly explanation. For many decades, tales have emerged from these waters like ancient whispers carried on the evening wind, ships that vanished without leaving a single trace behind, aircraft that disappeared into perfectly clear skies, leaving behind only haunting silence, compasses that spun wildly in circles, pointing towards some mysterious magnetic force beyond human understanding, radio signals that crackled with static and then died into nothingness. In the collective memory of our world, this stretch of deep ocean became something far more than simple water and salt. It became a doorway to the seemingly impossible. The stories grew richer and more elaborate with each telling, passed from sailor to sailor, from pilot to pilot. Mariners spoke in hushed voices of strange, pulsing lights that glowed beneath the waves like underwater stars. Experienced pilots reported sophisticated instruments failing mysteriously in perfect weather conditions. Search and rescue teams combed endless miles of empty ocean, finding nothing but vast expanses of blue water stretching to every horizon. The Bermuda Triangle became a name spoken with equal parts deep fascination and quiet fear, a place where the familiar laws of nature seem to bend and break like fragile glass. But what happens when the careful eye of science turns its patient, methodical gaze toward ancient mystery? When modern technology peers beneath the surface layers of legend and myth? When dedicated researchers armed with powerful satellites and advanced sonar equipment, with sophisticated deep-sea submersibles and complex computer models, begin to examine what truly lies beneath the accumulated myths of centuries? Today, as we stand at the very edge of new understanding, we find ourselves asking entirely different questions. The ocean here is far deeper than we once imagined, infinitely more complex than our ancestors could have dreamed in their wildest tales. The weather patterns are more violent and unpredictable than early explorers ever realized. The swift currents are more treacherous and changeable than old navigation charts could capture. The very floor of this ancient sea holds geological secrets that are only now beginning to emerge into the light of scientific discovery. Perhaps the greatest discovery of all is this profound realization. The Bermuda Triangle is not exactly what we thought it was for all these years, but it is something far more fascinating and wondrous than any supernatural tale. It is a place where the awesome, untamed power of nature meets the humble limits of human understanding, where rigorous science and enduring mystery dance together in the deep blue darkness of the ocean depths. As we begin this gentle journey into the very heart of the triangle tonight, we carry with us both the sophisticated tools of modern discovery and the timeless human need to understand the great unknown. The ocean keeps its secrets well, guarding them in the deepest trenches and strongest currents, but it is ready to share them generously with those who listen carefully to the ancient whispers of the deep. Let the soft rhythm of distant waves carry you peacefully toward rest as we prepare to explore one of the most enduring mysteries our world has ever known. On a warm December afternoon in 1945, beneath skies painted in gentle shades of blue and white, 5 Navy bombers lifted gracefully off from Fort Lauderdale, Florida. Flight 19, as history would remember it, began as nothing more than a routine training mission. The weather stretched endlessly clear across the horizon. The pilots were seasoned and experienced, the aircraft maintained with military precision. Yet 2 hours later, Lieutenant Charles Taylor's voice would crackle across the radio waves with words that would echo through decades of mystery. "We are entering white water. Nothing seems right. We don't know where we are. The water is green, no white." The radio transmissions that followed grew increasingly desperate with each passing minute, compasses spinning wildly in their housings like confused dancers, navigation instruments failing one by one in ways that defied explanation. The pilots, battle-tested veterans of World War II who had flown through enemy fire and survived the chaos of combat, began to sound increasingly confused and frightened. Then, as suddenly as it had begun, came only silence. 5 aircraft and 14 brave men vanished without leaving a single trace behind them. A rescue plane sent to find them also disappeared into the void, taking 13 more souls with it into the endless blue. This was not the first mysterious disappearance to occur in these ancient waters, but it would become the most famous, the most discussed, the most analyzed. 27 years earlier, during the First Great War, the USS Cyclops, a massive Navy cargo ship carrying precious manganese ore, had vanished somewhere between the tropical islands of Barbados and the busy port of Baltimore. 306 men disappeared with their ship into the depths. No desperate distress signal pierced the night. No twisted wreckage washed up on distant shores. No explanation ever emerged from the investigation that followed. The Cyclops was no ordinary vessel sailing the trade routes of the Atlantic. At 542 feet in length, she was one of the largest and most impressive ships in the Navy's entire fleet. Her massive cargo holds were filled to capacity with 10,000 tons of manganese ore, precious metal bound for the hungry steel mills of Baltimore, where it would be transformed into the backbone of American industry. Captain George Worley, a veteran mariner with decades of experience reading wind and weather, commanded a crew that knew these waters as well as any sailors alive. Yet on March 4, 1918, under circumstances that remain unclear to this day, the great ship simply vanished from the face of the earth. The disappearance haunted the halls of the Navy Department for many decades that followed. Search planes scoured thousands upon thousands of square miles of empty ocean, their crews scanning the horizon for any sign of wreckage or survivors. Ships diverted from their carefully planned courses to join the massive hunt, their captains hoping to be the ones to solve the mystery. The families of the missing sailors gathered around radios and waited for news that would never come, for answers that would never be found. In the thick official files that accumulated over the years, the loss was eventually attributed to enemy action, but no German submarine commander ever claimed the kill. No torpedo had been fired in anger. The great ship had simply sailed into nothingness, as if the ocean itself had reached up and pulled it down into the depths. These tragic incidents might have remained nothing more than sad footnotes in the long history of maritime disasters, curious tragedies in a profession that had always been dangerous and unpredictable. But in the 1950s, as the world emerged from the shadows of war and entered a bright new age of prosperity, something fundamental began to change in how these stories were told and remembered. The world was entering a revolutionary new age of mass media, of sensational headlines designed to catch the eye, of hungry audiences eager for excitement and mystery. Television sets flickered to life in living rooms across America. Radio programs reached millions of listeners each night. Magazines competed fiercely for readers' attention. Writers and journalists, always searching for stories that would capture the public imagination, discovered that mystery sold newspapers and filled movie theaters like nothing else could. The transformation of these maritime tragedies into something larger began quietly, almost accidentally. In 1950, a thoughtful reporter named E.V. W. Jones wrote a careful article about the strange pattern of disappearances, coining a phrase that would capture imaginations worldwide and change how people thought about this stretch of ocean: the Bermuda Triangle. His piece appeared in the Miami Herald, a respected local newspaper serving the very waters where these mysteries had unfolded over the decades. Jones had spent weeks speaking to Coast Guard officials, interviewing the grieving families of missing sailors, and poring over thick official records filled with technical details. His conclusions were measured and careful, his tone cautious and respectful of the human tragedy involved. But the story, once released into the world, took on a powerful life of its own that its creator could never have imagined. Other writers seized upon the compelling theme, each adding their own embellishments and interpretations. The disappearances became more mysterious with each retelling, the circumstances more bizarre and inexplicable. What had begun as careful, responsible journalism slowly transformed into something else entirely, something that would capture the imagination of the entire world. It was Vincent Gaddis, writing for the popular Argosy magazine in 1964, who truly brought the legend to vibrant life. His article, titled the deadly Bermuda Triangle painted a vivid picture of supernatural forces at work beneath the waves of the Atlantic. Gaddis was a skilled and experienced writer, a master of atmosphere and suspense who understood the human heart. He knew that readers craved mystery and wonder in an age of increasing scientific certainty when it seemed that every question was being answered and every secret revealed. The stories grew more elaborate and fantastic with each telling, passed from writer to writer like an ancient myth. Authors spoke of alien abductions occurring beneath the waves, of mysterious UFOs rising from hidden underwater bases. They described portals to other dimensions hidden beneath the surface, time warps that could swallow ships and planes whole. The lost city of Atlantis was said to rest somewhere in the depths, its ancient and powerful technology still wreaking havoc on modern vessels that passed overhead. In the colorful pages of these magazines, the Triangle became a realm of impossible phenomena where the normal laws of nature seemed suspended. Pilots reported their sophisticated instruments spinning wildly without cause, their radios suddenly filled with otherworldly static that seemed to come from nowhere. Ships were discovered drifting empty under the Caribbean sun, their crews vanished without explanation, meals still warm on galley tables as if the sailors had simply stepped away for a moment and never returned. But it was Charles Berlitz who would transform what had been local legend into a truly global phenomenon that would capture minds around the world. His 1974 book, The Bermuda Triangle, became an international bestseller, translated into dozens of languages and read by millions of fascinated readers. Berlitz skillfully wove together every mysterious disappearance he could find, creating an intricate tapestry of supernatural terror that captivated imaginations everywhere. Berlitz was uniquely positioned to tell this remarkable story to the world. The grandson of the founder of the famous Berlitz language schools, he had grown up in a cosmopolitan world of international travel and exotic locations. He spoke multiple languages fluently, had lived in many different countries, and possessed a natural gift for storytelling that made even the most outlandish claims seem not only plausible but compelling. The book described electronic fog that could mysteriously transport ships through time itself. It told of experienced pilots who found themselves flying through tunnels of brilliant light, emerging hours later with no memory of their strange journey. Ships were discovered drifting empty on calm seas, their crews vanished without explanation, as if they had been plucked from the deck by invisible hands. The ocean itself seemed alive with malevolent intelligence, watching and waiting for the next victim. Yet even as these extraordinary stories spread around the world like wildfire, capturing imaginations and inspiring countless books and films, a very different picture was quietly emerging in the methodical offices of insurance companies and maritime authorities. Lloyd's of London, the world's most famous and respected maritime insurers, kept meticulous records of every ship lost at sea anywhere in the world. Their thick files, filled with dry statistics and careful analysis, told a completely different story. The numbers were clear and unforgiving in their honesty. The Bermuda Triangle, despite its fearsome reputation in popular culture, was statistically no more dangerous than any other heavily traveled shipping lane anywhere in the world. The number of vessels lost in these waters was perfectly normal, even unremarkable, for a region that saw thousands of ships and aircraft pass through safely each year. The mystery, it seemed to those who looked carefully at the facts, existed only in the collective imagination. Coast Guard officials, who had spent their entire careers rescuing mariners in distress throughout these waters, spoke with quiet frustration about the persistent myths surrounding their familiar territory. They had personally investigated every significant disappearance, followed every promising lead, searched every mile of ocean with dedication and skill. In case after case, their careful investigations found mundane explanations, human error, mechanical failure, sudden violent storms that could sink a ship in minutes. The myth had been born from genuine tragedy, nurtured by sensational media hungry for readers, and sustained by our deepest fears and wildest hopes for mystery in an increasingly explained world. Families had indeed lost beloved sons and fathers in these waters. Sailors had faced very real dangers beneath tropical skies. Pilots had encountered genuine navigational challenges that tested their skills. Yet within this complex tapestry of legend and reality, threads of simple truth remained waiting to be found. Perhaps in our deep human hunger for mystery and wonder, we had overlooked the most fascinating truth of all, that the natural world around us was far more complex, beautiful, and unpredictable than any supernatural explanation could ever hope to be. The real Bermuda Triangle was not a realm of alien abductions or impossible time warps. It was something far more remarkable and worthy of wonder, a meeting place of powerful ocean currents, unpredictable weather patterns, and the endless human drama of those who dare to venture into the vast deep. If you were to stand on the sun-warmed beaches of Miami on a crystal-clear morning and gaze eastward across the endless expanse of the Atlantic, you would be looking into one corner of an invisible triangle that has captured the imagination of the entire world. The boundaries of this mysterious region are not marked by any physical landmarks, no ancient weathered stones or warning buoys bobbing in the waves. Instead, they exist in the collective consciousness of humanity, connecting three distant points scattered across the blue expanse: the bustling modern metropolis of Miami, the remote coral jewel of Bermuda, and the lush tropical shores of Puerto Rico. This vast triangle encompasses roughly 500,000 square miles of deep ocean, an area significantly larger than the entire state of Texas. Within these invisible boundaries lies a realm of water that has been traversed by countless thousands of ships and aircraft over the centuries, a busy crossroads of commerce and adventure that has witnessed more human activity than perhaps any other stretch of ocean anywhere on Earth. Yet to truly understand the nature of this region, we must look far beyond the accumulated myths and legends, beyond the captivating tales of supernatural phenomena that have grown up around it, and examine the actual physical geography that lies hidden beneath the rolling waves. For it is here, in the concrete reality of ocean depths and underwater mountain ranges, of powerful currents that flow like rivers beneath the sea, and shifting sands that cover ancient secrets, that we begin to discover the real explanations for the mysteries that have haunted these waters for generations. The western boundary of the triangle begins at Miami, a vibrant city that has grown from a small frontier trading post into one of the world's great international ports. From these busy harbors, massive cargo ships loaded with goods from across the Americas set sail daily for Europe and destinations beyond the horizon. Gleaming cruise ships carrying thousands of eager passengers embark on journeys to tropical paradises scattered throughout the Caribbean. Private yachts and commercial fishing vessels venture boldly into the Gulf Stream, seeking adventure or livelihood in the deep blue waters that stretch toward infinity. Miami sits perched at the very edge of the continental shelf, where the relatively shallow sunlit waters of the Florida coast suddenly drop away into the mysterious abyss of the deep ocean. Just a few miles offshore from the glittering hotels and beaches, the ocean floor plunges dramatically from depths of a few hundred feet to several thousand feet, creating underwater cliffs and precipices that rival any geological formation found on land. This dramatic underwater topography affects everything from local weather patterns to the behavior of ocean currents, creating complex conditions that can challenge even the most experienced and skillful mariners. The northern point of the triangle reaches toward Bermuda, a small emerald island that seems to float alone and isolated in the vast emptiness of the Atlantic. 650 miles from the nearest land, Bermuda sits like a tiny green jewel atop an ancient volcanic seamount, completely surrounded by coral reefs that have claimed countless ships over the long centuries of navigation. The island is actually composed of more than 150 small islands and rocky islets, connected by graceful bridges and narrow causeways, creating a complex maze of shallow channels and hidden waters. The approach to Bermuda remains treacherous even in our modern age of satellite navigation and radar. The island is surrounded by an almost continuous barrier of living coral reefs that extend for many miles in every direction beneath the surface. These reefs, while breathtakingly beautiful to observe from above, have been the doom of mariners for centuries untold. The razor-sharp coral rises suddenly from the depths, invisible to the eye until it is far too late, capable of tearing open the hull of any vessel that ventures too close to their hidden embrace. The southern boundary of the triangle extends to Puerto Rico, where the ocean holds perhaps its greatest and most profound secret. Here, just north of the tropical island, lies the Puerto Rico Trench, the deepest part of the entire Atlantic Ocean. This underwater canyon plunges more than 28,000 feet below the surface, deeper than Mount Everest reaches toward the sky. Within this immense trench, the ocean floor drops away into a darkness so complete and absolute that no ray of sunlight has ever penetrated its deepest depths. The Puerto Rico Trench is far more than merely a curiosity for marine scientists and oceanographers. It represents one of the most geologically active and unstable regions in the entire Atlantic Basin, where the massive North American and Caribbean tectonic plates meet in a slow-motion collision that has been ongoing for millions upon millions of years. This constant geological activity creates powerful underwater earthquakes, triggers massive landslides on the ocean floor, and generates the kinds of deep disturbances that can affect everything from delicate marine ecosystems to busy shipping lanes far above. Between these three widely scattered points, the hidden ocean floor tells a remarkable story of incredible geological complexity. Underwater mountain ranges rise majestically from the depths, their snow-covered peaks sometimes coming within just a few hundred feet of the surface where sunlight still penetrates. Deep valleys and gorges cut through the sea floor like ancient riverbeds carved by time itself, channels sculpted by powerful currents that have flowed steadily for countless millennia. Vast plains of accumulated sediment stretch for hundreds of miles in every direction, interrupted by dramatic canyons, jagged ridges and volcanic formations that create an underwater landscape as varied and spectacular as any found on the surface of our planet. Perhaps the most significant and influential feature of this underwater geography is the mighty Gulf Stream, a massive river of warm tropical water that flows steadily northward along the coast of Florida before turning eastward toward distant Europe. This enormous current, which can be more than 50 miles wide and 1,500 feet deep at its strongest points, moves at speeds of up to 5 miles per hour, carrying more than 30 times the combined flow of all the world's rivers put together. The Gulf Stream is far more than merely a current flowing through the ocean. It is a boundary between two completely different aquatic worlds. To the west lies the relatively warm, shallow water of the continental shelf where sea life thrives in the filtered sunlight. To the east stretches the deep, cold water of the Atlantic Basin where different creatures make their homes in eternal darkness. This boundary creates a zone of constant instability where weather systems can form and intensify with startling speed and power. The warm water of the Gulf Stream carries with it tremendous stored energy, heat that can fuel the rapid development of powerful storms and weather systems. During the long summer months, this accumulated heat combines with specific atmospheric conditions to create the thunderstorms and tropical cyclones that pose a constant threat to navigation throughout these waters. The sharp contrast between the warm stream and the cooler waters that surround it creates temperature gradients that can produce sudden fog banks, violent squalls, and unpredictable wind patterns that can catch even experienced sailors off guard. But the Gulf Stream's influence extends far beyond its effects on local weather patterns. The powerful current acts like a natural conveyor belt, rapidly dispersing and scattering anything that falls into its swift waters. Debris from a shipwreck or aircraft crash can be carried hundreds of miles within just a few days, scattered across vast areas of ocean and making recovery efforts nearly impossible for search teams. This natural dispersal effect has contributed significantly to many of the unsolved disappearances in the Triangle, as rescue teams looking for wreckage often focus their careful efforts in areas where the debris is no longer located. The dramatic depth changes within the Triangle are equally impressive and potentially dangerous. Near the palm-lined coasts of Florida and Puerto Rico, the water remains relatively shallow, often less than 200 feet deep and clear enough to see the sandy bottom. But move just a few miles offshore, and the bottom drops away precipitously into the abyss. Ships that encounter trouble in these areas may sink into waters so deep that they will never be found by human searchers, their final resting places far beyond the reach of any rescue or salvage operation that current technology can mount. These dramatic depth changes also significantly affect the behavior of the ocean itself in complex ways. Where deep water meets shallow in underwater cliffs and drop-offs, powerful upwelling currents can develop, bringing frigid water from the lightless depths to the warm surface. These upwelling zones can create areas of turbulence and unpredictable currents that challenge even the most modern and sophisticated navigation systems. Throughout this remarkable region, the ocean floor is scattered with the remains of countless ships and aircraft from every era of human travel, most of them victims not of supernatural forces or alien intervention, but of the very real and present dangers posed by this challenging geography. The combination of heavy maritime traffic, difficult navigation conditions, and harsh environmental factors has made these waters a vast underwater graveyard for vessels of every description and size. The triangle sits at the busy intersection of some of the world's most heavily traveled shipping lanes. Every single day, hundreds of cargo ships, massive tankers, and passenger vessels pass safely through these waters, carrying goods and people between the Americas, Europe, and the scattered islands of the Caribbean. The Port of Miami alone handles millions of tons of cargo annually, while the nearby Port Everglades serves as a major distribution hub for petroleum products and container ships from around the globe. This constant heavy traffic creates its own unique hazards and challenges. In congested shipping lanes where vessels travel in established patterns, the risk of collision increases dramatically. Large ships traveling at high speeds have very limited ability to maneuver quickly, and in areas where visibility can be suddenly reduced by fog or unexpected storms, the potential for disaster is ever present. The triangle's strategic position at the crossroads of major international shipping routes means that more vessels travel through these waters than almost any other area of comparable size anywhere in the world. The busy aviation routes that crisscross the triangle high above the waves are equally crowded with air traffic. Miami International Airport serves as a major hub for flights throughout the Americas and beyond, while smaller airports scattered throughout the Bahamas and Caribbean islands handle thousands of additional flights annually. The region's central position makes it a natural waypoint for aircraft traveling between North and South America, and the constant flow of air traffic creates additional complexity for navigation and air traffic control systems. Yet despite this incredibly heavy traffic, or perhaps precisely because of it, the triangle has somehow developed a reputation for supernatural danger that far exceeds any statistical reality. The ocean here is no more treacherous or mysterious than any other heavily traveled waterway anywhere in the world, but the combination of challenging geography, unpredictable weather patterns, and inevitable human error creates conditions where accidents are not only possible, but mathematically inevitable. The true mystery of the Bermuda Triangle may not be why ships and aircraft occasionally disappear in these waters, but rather why so many thousands more do not vanish without a trace. Every single day, thousands of vessels and aircraft navigate these waters safely and without incident, guided by modern technology and the accumulated wisdom of centuries of maritime experience. The Triangle's fearsome reputation has been built entirely on the relatively few tragic incidents that have occurred over the decades, not on the countless millions of safe passages that happen without notice, fanfare, or newspaper headlines. As we peer deeper into the Triangle's true geography with the patient eyes of science, we begin to see not a realm of supernatural danger and impossible phenomena, but rather a complex marine environment where entirely natural forces create very real hazards and challenges. The ocean floor rises and falls in dramatic formations sculpted by geological time, powerful currents flow with tremendous energy, and the meeting of different water masses creates conditions that can challenge even the most advanced navigation systems that human ingenuity has devised. Understanding the true geography of the Triangle does not diminish its power to fascinate us, but rather enhances it in ways that supernatural explanations never could. The real ocean that lies beneath these legendary waters is far more complex, dynamic, and awe-inspiring than any tale of alien visitation or impossible time warps could ever hope to be. In the eternal interplay of currents and depths, of weather and ancient geology, we find a story that is both more believable and more wonderful than any supernatural legend. The Triangle's enduring power to capture our imagination lies not in its reputation for otherworldly phenomena, but in its role as a window into the awesome natural forces that continue to shape our planet's vast oceans. Above the gently rolling waters of the Bermuda Triangle, the endless sky holds its own collection of ancient secrets. Here, where warm tropical air drifts up from the Caribbean and meets the cooler currents flowing down from the Atlantic, the atmosphere becomes a grand theater where dramatic performances can unfold with breathtaking speed and sometimes devastating power. To truly understand the mysteries that have long plagued these waters, we must turn our gaze upward toward the vast realm where clouds are born like cotton dreams and storms take shape from invisible forces. The triangle rests at a unique crossroads of atmospheric conditions, a magical meeting place where different air masses collide and dance together in patterns that weather scientists are only beginning to fully understand. The warm, moisture-laden air that rises like gentle breath from the tropical waters of the Caribbean encounters the cooler, drier air that flows steadily southward from the North American continent. When these contrasting air masses meet in their eternal dance, they create a zone of natural instability that can spawn weather phenomena ranging from gentle rain showers that kiss the ocean surface to catastrophic hurricanes that can reshape coastlines. Perhaps no weather phenomenon strikes more fear into the hearts of experienced pilots than the microburst, a localized downdraft of air that can develop with little warning and strike with the focused force of nature's own sledgehammer. These invisible columns of descending air can reach tremendous speeds of over 100 miles per hour, creating a cone of destruction that extends like a funnel from the clouds high above all the way down to the surface of the rolling ocean. For an aircraft caught unexpectedly in the grip of a microburst, the experience is like being grabbed by an enormous invisible hand and hurled relentlessly toward the waiting water below. Microbursts develop through a process that seems almost magical in its sudden appearance. When rain or hail begins to fall from a towering thundercloud, but evaporates completely before reaching the surface, this evaporation rapidly cools the surrounding air, making it much denser and heavier than the atmosphere around it. The cooled air then plunges downward like a stone dropped into still water, accelerating steadily as it falls until it strikes the ocean surface with tremendous force. Upon impact with the waves below, the downdraft spreads outward in all directions like ripples, creating a complex pattern of winds that can shift from helpful headwind to dangerous tailwind in a matter of seconds. For pilots flying at low altitudes above these waters, microbursts present a scenario that haunts their dreams. As an aircraft unknowingly enters the edge of the downdraft, it experiences a sudden increase in headwind that causes it to climb unexpectedly. Pilots, feeling their aircraft rising without their command, often reduce engine power instinctively to maintain their desired altitude. But as the aircraft passes through the center of the microburst and encounters the powerful downdraft, it begins to lose altitude rapidly and dangerously. When the pilot attempts to add power to arrest the descent, the aircraft emerges into a severe tailwind that further reduces lift and makes recovery nearly impossible even for the most skilled aviator. The triangle's unique position makes it particularly susceptible to this type of sudden microburst activity. The sharp contrast between the warm water of the Gulf Stream and the cooler air above creates ideal conditions for the development of these sudden atmospheric downdrafts. During the long summer months when atmospheric instability reaches its peak across the region, microbursts can develop almost anywhere within the triangle's invisible boundaries, often with no advance warning from even the most sophisticated weather radar systems. Equally dangerous and unpredictable are the rogue waves that can appear without any warning in even moderately rough seas. These massive walls of water, sometimes reaching heights of 60 feet or more, can completely overwhelm vessels that are perfectly capable of handling normal ocean swells and everyday maritime conditions. Unlike the regular, predictable wave patterns that experienced mariners learn to read and navigate like an ancient language, rogue waves appear suddenly and seemingly from nowhere, often traveling in groups of 3 or more, and can strike from directions that seem to defy the prevailing sea conditions and wind patterns. The formation of these monster rogue waves is a complex natural process that scientists around the world are still working diligently to understand fully. They appear to result from what oceanographers call the constructive interference of multiple wave systems, where waves traveling in different directions across the ocean meet and combine their accumulated energy into a single towering mass of water that rises like a liquid mountain from the sea. The triangle's strategic position at the confluence of different current systems creates ideal conditions for this type of wave interaction and energy concentration. The mighty Gulf Stream itself contributes significantly to rogue wave formation by creating areas where fast-moving current encounters opposing winds in natural conflict. When strong winds blow directly against the direction of the current, they can create steep, unstable waves that are prone to combining into larger and more dangerous formations. The result is a sea state that can change from manageable and peaceful to life-threatening and chaotic in a matter of minutes. Modern satellite imagery has revealed that the triangle experiences some of the most complex and rapidly changing weather patterns found anywhere on our planet. High-resolution images transmitted from space show spiral formations of clouds that appear and dissipate within hours, atmospheric disturbances that seem to materialize from nothing and vanish just as quickly into the blue. These remarkable images reveal a dynamic atmosphere in constant motion, where stability is the rare exception rather than the everyday rule. The fascinating phenomenon known as atmospheric gravity waves adds yet another layer of complexity to the triangle's ever-changing weather patterns. These are not the gravitational waves predicted by Einstein's theory of relativity, but rather rhythmic oscillations in the atmosphere caused by the interaction of air masses with different densities and temperatures. When stable air is forced to rise over a barrier such as a weather front or temperature gradient, it can create waves that propagate through the atmosphere like ripples spreading across a peaceful pond. These atmospheric gravity waves can travel for hundreds of miles across the ocean, carrying energy and precious moisture across vast distances. When these invisible waves encounter just the right conditions, they can trigger the rapid development of thunderstorms or other severe weather phenomena seemingly from clear skies. The triangle's unique position makes it a natural focal point for these atmospheric disturbances, as waves generated by weather systems throughout the Atlantic basin converge on this region like streams flowing toward a common destination. The seasonal hurricane activity that affects the triangle is perhaps the most well-documented and feared of its weather hazards. From June through November each year, the warm waters of the Atlantic serve as fuel for tropical cyclones that can grow from minor atmospheric disturbances to Category 5 monsters in a matter of days. The triangle lies directly in the traditional path of hurricanes that form off the distant coast of Africa and strengthen as they cross thousands of miles of open Atlantic water. But hurricanes are not the only tropical weather phenomena that affect these historically troubled waters. Tropical waves, areas of low pressure that move steadily westward across the Atlantic like invisible ships, can create sudden squalls and severe thunderstorms even when they do not develop into full hurricanes. These atmospheric disturbances can generate sustained winds of 50 to 70 miles per hour and spawn waterspouts that pose a significant threat to both aircraft flying overhead and surface vessels below. Waterspouts are essentially tornadoes that form over water, tall columns of rotating air that extend from the base of towering cumulus clouds all the way down to the ocean surface. While generally less powerful than their land-based cousins that terrorize the Great Plains, waterspouts can still pack winds of over 100 miles per hour and create a visible vortex capable of damaging or completely destroying small aircraft and boats. The triangle's consistently warm waters and unstable atmospheric conditions make it one of the most active waterspout regions anywhere in the world. The phenomenon of explosive cyclogenesis, sometimes called a weather bomb by meteorologists, represents one of the most dramatic examples of rapid weather development that can occur within the triangle's boundaries. This remarkable process involves the rapid intensification of a low-pressure system, with the central pressure dropping by at least 24 millibars in 24 hours. The result is a storm that can reach hurricane force intensity within a single day, often catching mariners and aviators completely unprepared for the sudden change. Temperature inversions add yet another dimension to the triangle's atmospheric complexity and unpredictability. These occur when a layer of warm air sits atop cooler air near the surface, creating a stable atmospheric condition that can trap moisture, pollutants, and even radio signals like a natural lid. Inversions can create optical illusions that make distant objects appear closer or farther than they actually are, leading to navigation errors and pilot disorientation that can have serious consequences. The constant interaction between the ocean and atmosphere in the triangle creates feedback loops that can amplify weather disturbances in unexpected ways. Warm water evaporates rapidly, adding moisture to the air and providing energy for storm development. As storms form and intensify, they can create areas of upwelling that bring cooler water to the surface, which can then affect subsequent weather patterns in a continuing cycle. This constant exchange of energy between sea and sky creates a dynamic system where small changes can have large and completely unpredictable effects. Modern meteorology has made great strides in understanding and predicting these atmospheric phenomena, but the triangle's weather still poses significant challenges to even the most experienced forecasters. The rapid development of severe weather can outpace even the most sophisticated forecasting models, and the complex interactions between different atmospheric systems can create conditions that are difficult to predict with certainty. Satellite technology has revolutionized our ability to observe and track weather patterns in the triangle from the safety of space. High-resolution images can capture the formation of individual thunderstorms, the development of tropical systems, and the movement of atmospheric disturbances across the region in real time. Doppler radar systems can detect the presence of microbursts, waterspouts, and other severe weather phenomena, providing advance warning to pilots and mariners who might otherwise find themselves in mortal danger. Yet despite these remarkable technological advances, the atmosphere above the triangle remains a realm of surprising complexity and occasional violence. The weather here is not supernatural or otherworldly, but it is undeniably powerful and sometimes unpredictable. The combination of warm tropical waters, complex current systems, and variable atmospheric conditions creates an environment where severe weather can develop rapidly and strike with little warning. The key to understanding the triangle's fearsome reputation may lie not in supernatural explanations or alien interventions, but in the very real and well-documented power of its atmospheric phenomena. Microbursts, rogue waves, explosive cyclogenesis, and rapid storm development can all create conditions that are dangerous enough to account for aircraft and vessel losses without invoking any paranormal causes or mysterious forces. For those brave souls who venture into these waters, whether by sea or air, the atmosphere above the triangle demands respect and careful preparation. Modern weather forecasting and detection equipment have made navigation safer than ever before, but they cannot eliminate the fundamental reality that this region experiences some of the most dynamic and potentially dangerous weather patterns found anywhere on Earth. The sky above the triangle tells an eternal story of constant change and occasional violence, of atmospheric forces that can transform a clear, peaceful day into a life-threatening situation in a matter of minutes. Understanding these forces does not diminish the mystery of the triangle, but rather reveals it to be a place where the raw power of nature is on constant display. A humbling reminder that even in our age of advanced technology, the atmosphere still holds the power to surprise and humble those who dare to challenge it. In the end, the greatest mystery of the triangle's weather may not be its occasional violence, but its incredible complexity and beauty. Here, in this relatively small patch of ocean, we can observe the full spectrum of atmospheric phenomena, from gentle trade winds that caress the waves to devastating hurricanes that reshape entire coastlines. The triangle serves as a natural laboratory where meteorologists can study the intricate dance between ocean and atmosphere, a dance that has been going on for millions of years and will continue long after the last ship has crossed these waters and the last plane has flown overhead. Deep beneath the rolling waves of the Bermuda Triangle, invisible forces move through the Earth itself, creating a magnetic landscape that has confused and challenged navigators for centuries. To understand the true nature of this region, we must journey into the realm of magnetism, where compass needles dance to the tune of forces far more ancient than human civilization, where the very planet's magnetic field tells a story of complexity that early sailors could never have imagined. The Earth's magnetic field is not the simple uniform force that many imagine it to be. Like a vast, invisible web that surrounds our planet, this magnetic field fluctuates and varies from place to place, creating a complex pattern of magnetic strength and direction that changes subtly across the surface of our world. In some regions, the field is strong and stable, providing reliable guidance to those who depend on magnetic compasses for navigation. In others, the field becomes weak or erratic, creating areas where traditional navigation becomes unreliable and sometimes dangerous. The Bermuda Triangle sits in one of these magnetically complex regions, where the Earth's magnetic field exhibits characteristics that can confuse even the most sophisticated navigational instruments. Here, the invisible lines of magnetic force that circle our planet converge and diverge in patterns that create what scientists call magnetic anomalies, areas where the expected behavior of magnetic compasses becomes unpredictable and sometimes completely unreliable. One of the most significant features affecting navigation in the triangle is the agonic line, an invisible boundary that moves slowly across the Earth's surface over the course of many years. Along this line, something remarkable occurs. The magnetic North Pole and the true North Pole align perfectly, creating a rare condition where compass needles point toward true north rather than magnetic north. For navigators who understand this phenomenon, the agonic line can actually improve navigation accuracy, but for those who are unaware of its presence, it can create confusion and navigational errors that have historically led to disaster. The agonic line is not fixed in place, but wanders slowly across the Earth's surface as the planet's magnetic field gradually shifts and changes. In the early to mid-20th century, this line passed directly through the Bermuda Triangle region, creating a zone where traditional navigation techniques had to be adjusted to account for the unusual magnetic conditions. Many of the mysterious disappearances that occurred during this period may have been influenced by navigational errors caused by pilots and mariners who were unaware of these special magnetic conditions. But the triangle's magnetic mysteries extend far beyond the simple alignment of magnetic and true north. The region experiences what geophysicists call magnetic declination variations, where the difference between magnetic north and true north changes more rapidly than in most other areas of the world. These variations can be subtle, sometimes changing by only a few degrees over the course of several miles, but even small navigational errors can have catastrophic consequences for aircraft flying at high speeds or ships navigating in dangerous waters. The underlying geology of the triangle contributes significantly to these magnetic anomalies. Beneath the ocean floor lie vast deposits of iron ore and other magnetic minerals, accumulated over millions of years of geological activity. These deposits create local magnetic fields that can interfere with compass readings, causing needles to deviate from their expected positions. The effect is similar to placing a compass near a large piece of iron. The needle responds to the local magnetic field rather than the Earth's overall magnetic field. The Puerto Rico Trench, that enormous underwater canyon that plunges more than 28,000 feet below the surface, plays a particularly important role in the region's magnetic complexity. The trench marks the boundary between two major tectonic plates, the North American plate and the Caribbean plate, which are slowly grinding against each other in a process that has been ongoing for millions of years. This geological activity creates areas of intense magnetic disturbance, where the normal patterns of the Earth's magnetic field become twisted and distorted. As these massive plates move and shift, they carry with them rocks that contain different magnetic properties. Some rocks are highly magnetic, containing large amounts of iron and other magnetic minerals. Others are virtually non-magnetic, having little effect on compass readings. When these different types of rock are brought together by tectonic movement, they create a patchwork of magnetic conditions that can vary dramatically over relatively short distances. The movement of the Gulf Stream also contributes to the triangle's magnetic complexity in ways that scientists are only beginning to understand. This massive current carries with it not only warm water but also dissolved minerals and particles that can affect local magnetic conditions. As the stream flows through the region, it creates subtle changes in the magnetic field that can influence compass readings, particularly in areas where the current is strongest. Modern scientific instruments have revealed that the triangle experiences what are known as magnetic storms, temporary disturbances in the Earth's magnetic field caused by solar activity. When charged particles from the Sun interact with our planet's magnetic field, they can create fluctuations that affect everything from radio communications to compass readings. The triangle's position makes it particularly susceptible to these magnetic storms, which can cause compass needles to swing wildly and electronic navigation systems to malfunction. These magnetic storms are not constant but occur in cycles that correspond to solar activity. During periods of high solar activity, when the sun is producing large numbers of charged particles, magnetic storms become more frequent and intense. During these times, navigation in the triangle becomes significantly more challenging, as both magnetic and electronic navigation systems can become unreliable. The phenomenon of magnetic inclination adds another layer of complexity to navigation in the triangle. This refers to the angle at which the Earth's magnetic field lines intersect the surface of the planet. In some areas, these field lines are nearly horizontal, while in others they plunge steeply toward the center of the Earth. The triangle sits in a region where magnetic inclination varies significantly, creating areas where compass needles may not only point in the wrong direction, but may also tilt at unexpected angles. For aircraft, magnetic navigation errors can be particularly dangerous because of the speeds at which they travel. A compass error of just a few degrees can cause an aircraft to deviate from its intended course by many miles over the course of a long flight. In the days before satellite navigation, pilots relied heavily on magnetic compasses for navigation, especially during overwater flights where there were no visual landmarks to provide guidance. The famous Flight 19 incident, where 5 Navy bombers disappeared during a training mission in 1945, may have been influenced by exactly this type of magnetic navigation error. Radio transmissions from the flight leader indicated that his compasses were behaving erratically, spinning wildly and providing inconsistent readings. Without reliable compass guidance, the formation may have become lost and flown far out to sea, eventually running out of fuel over the deep waters of the Atlantic. Ships face similar challenges when navigating in magnetically complex waters. Traditional marine navigation relied heavily on magnetic compasses, particularly during nighttime or in poor weather when celestial navigation was impossible. A ship's compass that suddenly began pointing in the wrong direction could easily lead the vessel off course, potentially into dangerous waters or away from its intended destination. The interaction between the triangle's magnetic anomalies and modern electronic navigation systems creates new types of challenges that early navigators never had to face. Electronic compasses, which are used in many modern aircraft and ships, can be even more sensitive to magnetic disturbances than traditional magnetic compasses. When these electronic systems encounter unexpected magnetic conditions, they may provide erroneous readings or shut down entirely, leaving navigators without reliable directional guidance. Global positioning system technology has largely solved the navigation problems that magnetic anomalies once created, but GPS is not infallible. Solar storms that affect magnetic fields can also interfere with GPS signals, and the system can be disrupted by atmospheric conditions or equipment failures. When GPS fails, navigators must fall back on traditional methods, including magnetic compasses, which brings them once again into contact with the triangle's complex magnetic environment. The study of paleomagnetism, the record of ancient magnetic fields preserved in rocks and sediments, reveals that the triangle's magnetic complexity is not a recent development, but has existed for millions of years. Core samples taken from the ocean floor show layers of sediment that were deposited when the Earth's magnetic field had different orientations, creating a geological record of magnetic changes that extends far back into prehistoric times. This ancient magnetic history suggests that the navigational challenges faced in the triangle are part of a much larger pattern of magnetic variation that affects the entire planet. The Earth's magnetic field is constantly changing, with the magnetic poles slowly moving and the strength of the field fluctuating over time. What we observe in the triangle today is simply one small part of this global magnetic story. Understanding the triangle's magnetic mysteries does not diminish the real dangers that these phenomena can pose to navigation. Magnetic anomalies, compass errors, and electronic navigation failures have contributed to genuine accidents and disappearances throughout the region's history. But these dangers are natural phenomena that can be understood, predicted, and planned for with proper knowledge and equipment. Modern navigation techniques have made it possible to account for most of the magnetic variations that occur in the triangle. Detailed magnetic charts show areas where compass readings may be unreliable, and electronic navigation systems can be programmed to compensate for known magnetic anomalies. Pilots and mariners who understand these conditions and plan accordingly can navigate safely through the region. The magnetic mysteries of the Bermuda Triangle remind us that our planet is a dynamic, ever-changing system where invisible forces are constantly at work. The magnetic field that guides our compasses is not a simple, unchanging reference but a complex phenomenon that reflects the ongoing geological and atmospheric processes that shape our world. In the triangle, this complexity is simply more visible, more concentrated, and more likely to affect human activities. As we drift deeper into understanding these magnetic mysteries, we find not supernatural forces or alien technology, but the beautiful complexity of our own planet's natural systems. The compass rose that has guided sailors for centuries continues to turn in response to forces that are both ancient and ongoing, powerful and subtle, mysterious yet ultimately comprehensible through the patient application of scientific knowledge. The magnetic landscape of the Bermuda Triangle stands as a testament to the intricate workings of our planet, a reminder that even the most fundamental tools of navigation must be understood within the context of a dynamic, ever-changing world. Here, where compass needles dance to magnetic melodies that have been playing for millions of years, we find not evidence of the supernatural, but proof of the enduring power and beauty of natural forces that continue to shape our world in ways both seen and unseen. Deep beneath the rolling waves of the Bermuda Triangle, invisible forces move through the Earth itself, creating a magnetic landscape that has confused and challenged navigators for centuries. To understand the true nature of this region, we must journey into the realm of magnetism, where compass needles dance to the tune of forces far more ancient than human civilization, where the very planet's magnetic field tells a story of complexity that early sailors could never have imagined. The Earth's magnetic field is not the simple, uniform force that many imagine it to be. Like a vast, invisible web that surrounds our planet, this magnetic field fluctuates and varies from place to place, creating a complex pattern of magnetic strength and direction that changes subtly across the surface of our world. In some regions, the field is strong and stable, providing reliable guidance to those who depend on magnetic compasses for navigation. In others, the field becomes weak or erratic, creating areas where traditional navigation becomes unreliable and sometimes dangerous. The Bermuda Triangle sits in one of these magnetically complex regions where the Earth's magnetic field exhibits characteristics that can confuse even the most sophisticated navigational instruments. Here, the invisible lines of magnetic force that circle our planet converge and diverge in patterns that create what scientists call magnetic anomalies, areas where the expected behavior of magnetic compasses becomes unpredictable and sometimes completely unreliable. One of the most significant features affecting navigation in the triangle is the agonic line, an invisible boundary that moves slowly across the Earth's surface over the course of many years. Along this line, something remarkable occurs. The magnetic North Pole and the true North Pole align perfectly, creating a rare condition where compass needles point toward true north rather than magnetic north. For navigators who understand this phenomenon, the agonic line can actually improve navigation accuracy, but for those who are unaware of its presence, it can create confusion and navigational errors that have historically led to disaster. The agonic line is not fixed in place but wanders slowly across the Earth's surface as the planet's magnetic field gradually shifts and changes. In the early to mid-20th century, this line passed directly through the Bermuda Triangle region, creating a zone where traditional navigation techniques had to be adjusted to account for the unusual magnetic conditions. Many of the mysterious disappearances that occurred during this period may have been influenced by navigational errors caused by pilots and mariners who were unaware of these special magnetic conditions. But the triangle's magnetic mysteries extend far beyond the simple alignment of magnetic and true north. The region experiences what geophysicists call magnetic declination variations, where the difference between magnetic north and true north changes more rapidly than in most other areas of the world. These variations can be subtle, sometimes changing by only a few degrees over the course of several miles, but even small navigational errors can have catastrophic consequences for aircraft flying at high speeds or ships navigating in dangerous waters. The underlying geology of the triangle contributes significantly to these magnetic anomalies. Beneath the ocean floor lie vast deposits of iron ore and other magnetic minerals accumulated over millions of years of geological activity. These deposits create local magnetic fields that can interfere with compass readings, causing needles to deviate from their expected positions. The effect is similar to placing a compass near a large piece of iron. The needle responds to the local magnetic field rather than the Earth's overall magnetic field. The Puerto Rico Trench, that enormous underwater canyon that plunges more than 28,000 feet below the surface, plays a particularly important role in the region's magnetic complexity. The trench marks the boundary between two major tectonic plates, the North American plate and the Caribbean plate, which are slowly grinding against each other in a process that has been ongoing for millions of years. This geological activity creates areas of intense magnetic disturbance, where the normal patterns of the Earth's magnetic field become twisted and distorted. As these massive plates move and shift, they carry with them rocks that contain different magnetic properties. Some rocks are highly magnetic, containing large amounts of iron and other magnetic minerals. Others are virtually non-magnetic, having little effect on compass readings. When these different types of rock are brought together by tectonic movement, they create a patchwork of magnetic conditions that can vary dramatically over relatively short distances. The movement of the Gulf Stream also contributes to the triangle's magnetic complexity in ways that scientists are only beginning to understand. This massive current carries with it not only warm water, but also dissolved minerals and particles that can affect local magnetic conditions. As the stream flows through the region, it creates subtle changes in the magnetic field that can influence compass readings, particularly in areas where the current is strongest. Modern scientific instruments have revealed that the triangle experiences what are known as magnetic storms, temporary disturbances in the Earth's magnetic field caused by solar activity. When charged particles from the Sun interact with our planet's magnetic field, they can create fluctuations that affect everything from radio communications to compass readings. The triangle's position makes it particularly susceptible to these magnetic storms, which can cause compass needles to swing wildly and electronic navigation systems to malfunction. These magnetic storms are not constant, but occur in cycles that correspond to solar activity. During periods of high solar activity, when the Sun is producing large numbers of charged particles, magnetic storms become more frequent and intense. During these times, navigation in the triangle becomes significantly more challenging, as both magnetic and electronic navigation systems can become unreliable. The phenomenon of magnetic inclination adds another layer of complexity to navigation in the triangle. This refers to the angle at which the Earth's magnetic field lines intersect the surface of the planet. In some areas, these field lines are nearly horizontal, while in others they plunge steeply toward the center of the Earth. The triangle sits in a region where magnetic inclination varies significantly, creating areas where compass needles may not only point in the wrong direction but may also tilt at unexpected angles. For aircraft, magnetic navigation errors can be particularly dangerous because of the speeds at which they travel. A compass error of just a few degrees can cause an aircraft to deviate from its intended course by many miles over the course of a long flight. In the days before satellite navigation, pilots relied heavily on magnetic compasses for navigation, especially during overwater flights where there were no visual landmarks to provide guidance. The famous Flight 19 incident, where 5 Navy bombers disappeared during a training mission in 1945, may have been influenced by exactly this type of magnetic navigation error. Radio transmissions from the flight leader indicated that his compasses were behaving erratically, spinning wildly and providing inconsistent readings. Without reliable compass guidance, the formation may have become lost and flown far out to sea, eventually running out of fuel over the deep waters of the Atlantic. Ships face similar challenges when navigating in magnetically complex waters. Traditional marine navigation relied heavily on magnetic compasses, particularly during nighttime or in poor weather when celestial navigation was impossible. A ship's compass that suddenly began pointing in the wrong direction could easily lead the vessel off course, potentially into dangerous waters or away from its intended destination. The interaction between the triangle's magnetic anomalies and modern electronic navigation systems creates new types of challenges that early navigators never had to face. Electronic compasses, which are used in many modern aircraft and ships, can be even more sensitive to magnetic disturbances than traditional magnetic compasses. When these electronic systems encounter unexpected magnetic conditions, they may provide erroneous readings or shut down entirely, leaving navigators without reliable directional guidance. Global positioning system technology has largely solved the navigation problems that magnetic anomalies once created, but GPS is not infallible. Solar storms that affect magnetic fields can also interfere with GPS signals, and the system can be disrupted by atmospheric conditions or equipment failures. When GPS fails, navigators must fall back on traditional methods, including magnetic compasses, which brings them once again into contact with the triangle's complex magnetic environment. The study of paleomagnetism, the record of ancient magnetic fields preserved in rocks and sediments, reveals that the triangle's magnetic complexity is not a recent development but has existed for millions of years. Core samples taken from the ocean floor show layers of sediment that were deposited when the Earth's magnetic field had different orientations, creating a geological record of magnetic changes that extends far back into prehistoric times. This ancient magnetic history suggests that the navigational challenges faced in the triangle are part of a much larger pattern of magnetic variation that affects the entire planet. The Earth's magnetic field is constantly changing, with the magnetic poles slowly moving and the strength of the field fluctuating over time. What we observe in the triangle today is simply one small part of this global magnetic story. Understanding the triangle's magnetic mysteries does not diminish the real dangers that these phenomena can pose to navigation. Magnetic anomalies, compass errors, and electronic navigation failures have contributed to genuine accidents and disappearances throughout the region's history. But these dangers are natural phenomena that can be understood, predicted, and planned for with proper knowledge and equipment. Modern navigation techniques have made it possible to account for most of the magnetic variations that occur in the triangle. Detailed magnetic charts show areas where compass readings may be unreliable, and electronic navigation systems can be programmed to compensate for known magnetic anomalies. Pilots and mariners who understand these conditions and plan accordingly can navigate safely through the region. The magnetic mysteries of the Bermuda Triangle remind us that our planet is a dynamic, ever-changing system where invisible forces are constantly at work. The magnetic field that guides our compasses is not a simple, unchanging reference, but a complex phenomenon that reflects the ongoing geological and atmospheric processes that shape our world. In the triangle, this complexity is simply more visible, more concentrated, and more likely to affect human activities. As we drift deeper into understanding these magnetic mysteries, we find not supernatural forces or alien technology, but the beautiful complexity of our own planet's natural systems. The compass rose that has guided sailors for centuries continues to turn in response to forces that are both ancient and ongoing, powerful and subtle, mysterious yet ultimately comprehensible through the patient application of scientific knowledge. The magnetic landscape of the Bermuda Triangle stands as a testament to the intricate workings of our planet, a reminder that even the most fundamental tools of navigation must be understood within the context of a dynamic, ever-changing world. Here, where compass needles dance to magnetic melodies that have been playing for millions of years, we find not evidence of the supernatural, but proof of the enduring power and beauty of natural forces that continue to shape our world in ways both seen and unseen. In the gentle rhythm of waves against a ship's hull and the steady hum of aircraft engines cutting through tropical air, we find the most important element of any journey across the Bermuda Triangle, the human spirit. For all the talk of mysterious forces and supernatural phenomena, the greatest factor in both the triumphs and tragedies of these waters has always been the people who venture into them, carrying with them the full spectrum of human strengths and weaknesses, courage and fear, wisdom and error. The ocean is an unforgiving teacher that demands respect from all who sail upon its surface. It cares nothing for experience or reputation, showing equal indifference to the seasoned captain with decades of service and the weekend sailor on his first voyage beyond sight of land. In the vast expanse of the triangle, where help can be hundreds of miles away and rescue may take days to arrive, every decision matters. Every mistake can have consequences that ripple far beyond the moment of their making. Consider the story of the Marine Sulphur Queen, a tanker that vanished in February of 1963 while carrying a cargo of molten sulfur from Texas to Virginia. This was no small pleasure craft piloted by inexperienced hands, but a substantial commercial vessel operated by a professional crew. Yet investigations following her disappearance revealed a troubling pattern of mechanical problems, structural weaknesses, and safety violations that had been accumulating for years. The ship had been showing signs of stress and fatigue for months before her final voyage. Crew members had reported cracks in the hull, problems with the heating system that kept the sulfur cargo in liquid form, and concerns about the vessel's overall seaworthiness. But commercial pressures, schedule demands, and the human tendency to normalize risk had kept the ship sailing despite these warning signs. When she finally foundered somewhere in the triangle, it was not supernatural forces that claimed her, but the accumulated weight of human decisions made over time. This pattern of human error and mechanical neglect appears again and again in the triangle's history of maritime disasters. Ships sailing with inadequate safety equipment, crews who had not received proper training for emergency situations, captains who pushed their vessels beyond safe limits in pursuit of faster passage times or higher profits. The ocean reveals these human failings with merciless clarity, but it is not the ocean that creates them. In the golden age of aviation, when Flight 19 made its fateful journey into legend, pilot training and navigation procedures were far different from what we know today. Military aviators of that era learned to fly by the seat of their pants, relying on visual landmarks and basic instruments to find their way across the sky. Radio navigation was primitive by modern standards, and the concept of redundant backup systems had not yet evolved to the sophisticated levels we take for granted in contemporary aircraft. Lieutenant Charles Taylor, the leader of Flight 19, was an experienced pilot who had flown combat missions during World War II. But experience in the controlled environment of military bases and well-charted coastal waters did not necessarily translate to confidence in the vast emptiness of the Atlantic Ocean. Radio transmissions from that December afternoon reveal a pilot who became increasingly confused about his position, convinced that his compass was malfunctioning, and ultimately making decisions based on false assumptions about where he was. The human factor in Taylor's confusion cannot be overlooked. He had recently transferred to the Florida base and was not familiar with the local geography. The flight was supposed to be a routine training mission, but weather conditions began to deteriorate as the afternoon progressed. Under stress, with responsibility for 4 other aircraft and their crews, Taylor made a series of navigation errors that compounded upon each other until the formation was hopelessly lost over the deep waters of the Atlantic. What makes this tragedy particularly poignant is that other pilots in the formation apparently had different ideas about their location and the correct course to fly home. Radio transmissions suggest that at least one other pilot believed they should turn west toward land, while Taylor insisted on flying east. In the military hierarchy of that era, junior pilots did not question their flight leaders' decisions, even when those decisions might be leading them toward disaster. Modern accident investigation has revealed that human error plays a role in the vast majority of aviation and maritime accidents worldwide. Pilot error, mechanical failure, weather-related poor judgment, inadequate maintenance, communication breakdowns, and simple fatigue all contribute to a complex web of factors that can turn a routine journey into a tragedy. The Triangle's reputation for mystery has often obscured these human elements, creating a mythology that overlooks the very real and preventable causes of many accidents. The pressure to maintain schedules and meet deadlines has always been a significant factor in transportation disasters. Commercial operators, whether running cargo ships or passenger flights, operate in an environment where delays cost money and reputation. This economic pressure can lead to decisions that prioritize efficiency over safety, pushing crews to fly or sail in marginal weather conditions, to defer maintenance that should be performed immediately, or to cut corners in training and preparation. In the Triangle, where weather can change rapidly and conditions can deteriorate without warning, these pressures become even more dangerous. a captain who decides to outrun an approaching storm rather than seek shelter, a pilot who chooses to continue a flight despite growing concerns about fuel consumption, a crew that fails to properly check safety equipment before departure. These seemingly small decisions can have enormous consequences when things begin to go wrong. The phenomenon of normalization of deviance, where dangerous conditions gradually become accepted as normal through repeated exposure, has played a role in many triangle incidents. When a ship's engine shows signs of wear but continues to function, when an aircraft's navigation system occasionally gives erroneous readings but usually works correctly, when safety procedures are frequently skipped without apparent consequence, crews can develop a false sense of security that makes them vulnerable when conditions suddenly deteriorate. Technology has always been a double-edged sword in maritime and aviation operations. While modern navigation systems, weather forecasting, and communication equipment have made travel much safer, they have also created new types of dependency and vulnerability. Crews who rely heavily on electronic systems may lose the traditional skills of dead reckoning, celestial navigation, and weather reading that allowed earlier generations of mariners and pilots to operate safely with simpler equipment. When electronic systems fail, as they inevitably do from time to time, modern crews may find themselves more helpless than their predecessors would have been in similar circumstances. The triangle's complex magnetic environment and susceptibility to atmospheric disturbances can affect electronic equipment in ways that crews may not anticipate, leading to navigation errors and communication failures that compound other problems. The psychology of emergency situations also plays a crucial role in determining outcomes when things go wrong in the triangle. Under stress, human beings often make decisions that seem irrational in hindsight, but make perfect sense given the limited information and intense pressure of the moment. Panic can cause experienced professionals to abandon established procedures, while denial can prevent crews from recognizing the severity of their situation until it is too late to take effective action. The isolation factor in triangle operations cannot be underestimated. When a ship or aircraft encounters problems in coastal waters or over land, help is usually relatively close at hand. But in the deep waters of the triangle, vessels may be hundreds of miles from the nearest rescue facility. This isolation creates psychological pressure that can affect decision-making, leading crews to take risks they might not consider in areas where rescue is more readily available. Search and rescue operations in the triangle face unique challenges that can affect their success rates. The vast area to be covered, the depth of the water in many locations, the speed of the Gulf Stream in dispersing debris, and the complex weather patterns that can hamper search efforts all combine to make rescue operations more difficult than in most other maritime regions. When search efforts fail to locate missing vessels or aircraft, the lack of wreckage or survivors often feeds speculation about supernatural causes rather than highlighting the practical difficulties of finding small objects in an enormous ocean. The role of fatigue in triangle incidents cannot be overlooked. Long-distance flights and extended voyages place significant physical and mental stress on crews, particularly when they encounter unexpected challenges or delays. Fatigue affects judgment, slows reaction times, and can lead to mistakes that well-rested crews would easily avoid. The triangle's position as a crossroads for long-distance travel means that many of the aircraft and ships that pass through are operated by crews who may already be operating at the limits of their endurance. Training standards and certification requirements have evolved significantly since many of the triangle's most famous incidents occurred. Modern pilots and mariners receive much more comprehensive instruction in emergency procedures, weather recognition, and navigation techniques than their predecessors. Simulator training allows crews to practice dealing with emergency situations in a safe environment, building muscle memory and decision-making skills that can prove crucial when real emergencies arise. Despite these improvements in training and technology, the human element remains the most unpredictable factor in any journey across the triangle. The best equipment in the world cannot compensate for poor judgment, and the most comprehensive training cannot prepare crews for every possible scenario they might encounter. The ocean and atmosphere continue to present challenges that test human skills, courage, and wisdom in ways that no amount of technological advancement can completely eliminate. Understanding the human factor in triangle incidents does not diminish the courage and skill of those who make their living on these waters. Professional mariners and aviators demonstrate remarkable competence and bravery in their daily operations, successfully completing thousands of safe transits for every tragic incident that makes headlines. Their expertise and dedication are what make modern transportation as safe as it is, even in challenging environments like the Triangle. The stories of Triangle disappearances are, fundamentally, human stories. They speak of people making difficult decisions under pressure, of crews working together to overcome challenges, of families waiting anxiously for loved ones to return safely home. In focusing too heavily on supernatural explanations, we risk losing sight of the human drama that lies at the heart of these events, the very real people whose lives were affected by the intersection of human capability and natural forces. As we drift through these waters of human experience, we find that the greatest mysteries of the Bermuda Triangle are not supernatural but deeply human. They involve the eternal challenge of people pushing against the boundaries of the possible, venturing into environments that test the limits of human skill and courage. In this light, the Triangle becomes not a realm of otherworldly phenomena, but a stage where the human drama of exploration, risk, and the eternal quest to overcome natural obstacles continues to unfold with each passing day. Far below the surface of the Bermuda Triangle, where sunlight fades into eternal twilight and then into complete darkness, the ocean floor holds secrets that dwarf any surface mystery. Here, in the crushing depths where pressure can flatten submarines like tin cans and cold reigns eternal, geological forces have been at work for millions of years, shaping an underwater landscape that is both beautiful and potentially dangerous to those who travel in the waters far above. The seafloor beneath the Triangle is not the flat, featureless plain that early oceanographers once imagined. Instead, it is a realm of dramatic mountains and valleys, of volcanic peaks that rise thousands of feet from the ocean floor and trenches that plunge deeper than any canyon on land. This hidden topography creates currents, influences weather patterns, and generates natural phenomena that can affect surface conditions in ways that scientists are only beginning to understand. In the deepest parts of the Triangle lies the Puerto Rico Trench, a massive underwater canyon that stretches like a great scar across the ocean floor. This trench, which plunges more than 28,000 feet below the surface, represents one of the most geologically active areas in the Atlantic Ocean. Here, the very foundations of the Earth are in motion, as massive tectonic plates grind against each other in a slow-motion collision that has been ongoing for millions of years. The movement of these enormous plates creates underwater earthquakes that can generate tsunamis, trigger landslides, and cause sudden changes in ocean depth. While major earthquakes in this region are relatively rare, smaller tremors occur regularly, creating vibrations that travel through the water and can affect everything from marine life to the operation of sensitive instruments on ships and aircraft passing overhead. Along the edges of the Puerto Rico Trench, underwater landslides have carved dramatic scars in the ocean floor. These massive movements of sediment and rock, some involving millions of tons of material, can happen without warning and create temporary changes in ocean currents and water temperature. When these landslides occur, they can generate underwater avalanches that travel for miles across the ocean floor, redistributing sediment and creating new topographical features. The geological instability of the region extends beyond the Puerto Rico Trench to include numerous underwater volcanoes and volcanic vents scattered across the Triangle's seafloor. Many of these volcanoes have been dormant for thousands of years, but others remain active, occasionally releasing gases and heated water into the surrounding ocean. These underwater volcanic activities can create localized changes in water temperature and chemistry that may affect marine life and ocean conditions. One of the most intriguing geological phenomena found in the Triangle is the presence of what scientists call methane hydrates, sometimes known as fire ice. These crystalline structures form when methane gas becomes trapped in ice-like formations on the cold ocean floor. Under the right conditions of temperature and pressure, these hydrates can become unstable and release large quantities of methane gas into the water column above. When methane hydrates decompose rapidly, they can create dramatic changes in the density of seawater. The released gas forms bubbles that rise toward the surface, reducing the overall density of the water and potentially affecting the buoyancy of ships. In theory, a large methane release could create an area of water so filled with gas bubbles that it would no longer support the weight of a vessel, causing it to sink rapidly. However, extensive scientific investigation has found little evidence that methane hydrate deposits in the triangle are large enough or unstable enough to pose a significant threat to surface shipping. While these formations do exist in various parts of the ocean floor beneath the triangle, they appear to be relatively stable under current conditions. The dramatic methane releases that some have theorized could explain mysterious ship disappearances remain largely theoretical rather than observed phenomena. The complex underwater topography of the triangle creates a network of ocean currents that can be far more intricate than the surface Gulf Stream that is visible to ships and aircraft. Deep water currents flowing along the ocean floor and through underwater valleys can create upwelling zones where cold water from the depths rises to the surface. These upwelling areas can create sudden temperature changes that affect local weather patterns and create conditions that are challenging for navigation. The interaction between surface currents and underwater topography can also create what oceanographers call standing waves, areas where the motion of water creates patterns that remain relatively stationary despite the constant flow of the current. These standing waves can create zones of turbulence that extend from the ocean floor to the surface, potentially affecting the stability of ships passing overhead. Underwater canyons carved into the continental shelf create acoustic shadows that can interfere with sonar systems and underwater communication equipment. Sound waves, which travel efficiently through water under normal conditions, can be reflected, refracted, or absorbed when they encounter the steep walls and complex geometry of these underwater formations. This acoustic interference can affect everything from depth soundings to submarine detection, creating areas where normal underwater navigation becomes more difficult. The sediment layers that cover much of the triangle's ocean floor tell a story of geological history that spans millions of years. Core samples taken from these sediments reveal evidence of ancient climate changes, volcanic eruptions, and massive storms that have affected the region throughout its history. Some of these sediment layers contain evidence of sudden, catastrophic events such as underwater landslides or volcanic eruptions that redistributed enormous amounts of material across the ocean floor. The weight of these accumulated sediments can create instability in certain areas of the ocean floor. When sediment layers become too thick or when they are disturbed by earthquakes or other geological activity, they can suddenly shift or collapse, creating underwater landslides that generate waves and currents far above. These sediment flows can travel at surprising speeds across the ocean floor, carving new channels and redistributing material over vast areas. Coral reefs and underwater formations in the shallower areas of the triangle create their own unique challenges for navigation. The living coral that builds these reefs is constantly growing and changing, creating new obstacles that may not appear on older nautical charts. The complex three-dimensional structure of coral reefs can create unexpected currents and eddies that can affect the handling characteristics of small boats and aircraft operating at low altitudes. The triangle's position at the boundary between different oceanic regions means that its seafloor receives sediments and materials from multiple sources. Rivers flowing from North America carry different types of sediment than those originating in the Caribbean, creating a complex mixture of materials on the ocean floor. This diversity of sediment types can create areas with different acoustic and magnetic properties, potentially affecting navigation and communication systems. Salt domes, massive underground formations of rock salt that have been pushed upward by geological pressure, create irregularities in the ocean floor that can affect local magnetic fields and create unexpected navigational challenges. These formations, some of which rise thousands of feet from the surrounding seafloor, can create localized magnetic anomalies that may interfere with compass readings and electronic navigation systems. The presence of numerous shipwrecks scattered across the triangle's ocean floor creates an archaeological record of maritime disasters that spans centuries of human activity in the region. These wrecks, ranging from wooden sailing ships to modern steel vessels, provide evidence of the ongoing challenges that mariners have faced in these waters. The distribution and condition of these wrecks also provide insights into the natural forces that affect objects on the ocean floor, including the action of currents, the effects of corrosion, and the gradual burial by sediment. Modern deep-sea exploration using remotely operated vehicles and advanced sonar systems has revealed that the triangle's ocean floor is far more complex and dynamic than early researchers ever imagined. High-resolution mapping has identified previously unknown underwater mountains, valleys, and geological formations that create a landscape as varied as any found on the surface of the continents. The discovery of underwater rivers, where dense, salt-laden water flows along the ocean floor like a river flowing through air, has added another dimension to our understanding of deep ocean currents in the triangle. These underwater rivers can flow for hundreds of miles, carrying sediments, marine life, and dissolved materials across vast distances. The interaction between these deep currents and surface conditions can create complex patterns of water movement that affect everything from local weather to the distribution of marine life. Hydrothermal vents, where heated water from deep within the earth emerges through cracks in the ocean floor, create localized ecosystems that are completely independent of sunlight. These vents, while not common in the Triangle region, do exist in some areas and create unique chemical and thermal conditions that can affect the surrounding ocean environment. The heated water from these vents can create localized temperature anomalies that may affect surface conditions hundreds of feet above. The study of the Triangle's seafloor continues to reveal new insights into the complex geological processes that shape our planet's oceans. Each deep-sea expedition brings back data that adds to our understanding of how underwater topography, geological activity, and ocean chemistry interact to create the complex marine environment that exists in this region. As we descend through these dark waters of understanding, we find that the ocean floor beneath the Triangle is not a static, unchanging foundation, but a dynamic landscape where geological forces continue to shape and reshape the underwater world. The mountains that rise from these depths, the valleys that cut through ancient sediments, and the ongoing geological processes that continue to modify this underwater terrain all contribute to the complex marine environment that has challenged and fascinated humans for generations. The seafloor of the Bermuda Triangle stands as a testament to the power of geological time and the ongoing forces that shape our planet. Here, in the crushing darkness of the deep ocean, we find not supernatural mysteries, but the slow, patient work of natural processes that have been sculpting the Earth for billions of years. The true wonder of this underwater realm lies not in its ability to make ships and planes disappear, but in its role as a window into the fundamental forces that continue to shape our living planet. In the quiet corners of human consciousness, where logic meets longing and the known world touches the edges of dreams, the Bermuda Triangle has found its most fertile ground. Here, beyond the reach of scientific instruments and careful measurement, the Triangle has grown into something far larger than its physical boundaries, becoming a canvas upon which humanity has painted its deepest fears and wildest hopes about the mysteries that might exist just beyond our understanding. The transformation of the Triangle from a geographical location into a realm of supernatural possibility began in the collective imagination of a world hungry for wonder. In an age when science seemed to be explaining away all the mysteries of existence, when maps had been drawn of every continent and photographs taken of the most distant mountains, the Triangle offered something precious, a place where anything might still be possible, where the impossible could happen on any ordinary Tuesday afternoon. The stories that grew up around these waters began simply enough, with genuine questions about real disappearances and actual navigation challenges. But as these stories passed from person to person, from book to magazine to television documentary, they began to evolve, taking on new details and supernatural explanations that transformed mundane maritime accidents into evidence of forces beyond human comprehension. In the popular imagination, the Triangle became a place where time itself behaved differently, where ships could sail from 1945 and emerge decades later with their crews having aged only minutes. Stories circulated of aircraft that vanished from radar screens only to reappear hours later, their pilots confused and disoriented, claiming that only moments had passed while the rest of the world had moved forward in time. These tales of temporal displacement appealed to something deep in the human psyche, our eternal fascination with the possibility that time might not be the rigid, unforgiving ruler we experience in our daily lives. The idea of dimensional portals added another layer to the triangle's mystique, suggesting that these waters might serve as a gateway between different realities. In this version of the legend, ships and planes did not sink or crash but simply passed through invisible doorways into parallel worlds, alternate dimensions where they continued their journeys in realms beyond our perception. The appeal of such stories lay not just in their exotic nature but in their promise that death and loss might not be final, that missing loved ones might continue to exist somewhere beyond the veil of ordinary reality. Extraterrestrial explanations for triangle phenomena captured imaginations during the height of UFO interest in the latter half of the 20th century. These theories suggested that alien civilizations had established underwater bases in the deep waters of the triangle, hidden cities of advanced technology from which they conducted mysterious experiments on human vessels that wandered too close to their secret operations. The idea that highly evolved beings from distant stars might be studying humanity from secret bases beneath familiar waters combined the thrill of cosmic contact with the comfort of terrestrial geography. The lost city of Atlantis found new life in triangle mythology, with some theorists suggesting that the legendary civilization described by ancient Greek philosophers lay beneath these particular waters. In these imaginative reconstructions, Atlantis had not been destroyed but had retreated beneath the waves, its advanced technology still functioning after thousands of years. The mysterious disappearances in the triangle were attributed to Atlantean devices that were still operational, inadvertently affecting modern vessels with energies and technologies far beyond contemporary human understanding. These supernatural explanations for triangle phenomena served important psychological functions for those who embraced them. In a world that often seemed cold and mechanistic, where scientific explanations reduced wonder to mere chemistry and physics, the triangle offered refuge for those who yearned for magic and mystery. The idea that somewhere on Earth the impossible could still happen provided comfort to those who felt overwhelmed by the apparent predictability of modern existence. The appeal of triangle mysteries also lay in their democratic nature. Unlike the distant mysteries of black holes or quantum mechanics, which required advanced education to even begin to understand, the triangle's secrets seemed accessible to anyone. A person did not need a doctorate in physics to have an opinion about what might be happening in these waters. The lack of definitive scientific explanations left room for every imagination to contribute its own theories and interpretations. Television documentaries and popular books amplified these supernatural explanations, often presenting them with the same apparent authority as scientific theories. The visual medium of television was particularly effective at making the impossible seem plausible, using dramatic reenactments, ominous music, and authoritative narration to create an atmosphere where fantastic explanations seemed not only possible but likely. The boundary between entertainment and education became blurred, with many viewers unable to distinguish between documented facts and imaginative speculation. The internet age brought new dimensions to triangle mythology, allowing stories to spread faster and evolve more rapidly than ever before. Online forums and websites dedicated to paranormal phenomena created communities where believers could share experiences, theories, and evidence that would never have found acceptance in mainstream scientific publications. The democratic nature of internet publishing meant that any theory, no matter how speculative, could find an audience and gain followers. Computer graphics and digital effects made it easier than ever to create convincing visual evidence of supernatural triangle phenomena. Photographs of UFOs emerging from the water, videos of ships disappearing into dimensional portals, and satellite images showing impossible atmospheric formations could be created with relatively simple software and shared instantly around the world. The line between genuine documentation and creative fiction became increasingly difficult for casual observers to distinguish. The commercialization of triangle mysteries created economic incentives for the continued promotion of supernatural explanations. Tour operators offering trips to triangle hotspots, authors writing books about impossible phenomena, and television producers creating documentaries about unexplained disappearances all had financial reasons to keep the supernatural aspects of the triangle alive in public consciousness. The more mysterious and inexplicable the triangle appeared, the more attractive it became to consumers of entertainment and adventure. Psychological research has revealed that humans have a natural tendency to prefer dramatic, intentional explanations for events over mundane, accidental ones. The idea that a ship disappeared because of alien intervention or dimensional displacement is somehow more psychologically satisfying than the explanation that it sank due to mechanical failure or human error. This cognitive bias, known as agency detection, predisposes people to see intention and purpose in random events, making supernatural explanations inherently appealing. The role of confirmation bias in perpetuating triangle myths cannot be overlooked. Once people become convinced that supernatural forces operate in these waters, they tend to interpret new information in ways that support their existing beliefs while dismissing or ignoring evidence that contradicts them. Successful flights and voyages through the triangle are forgotten, while any unusual incident is seen as confirmation of mysterious forces at work. The phenomenon of pareidolia, where the human brain perceives patterns and familiar shapes in random or ambiguous stimuli, has contributed to many triangle sightings and experiences. Clouds that happen to form unusual shapes, wave patterns that create optical illusions, and equipment malfunctions that produce strange readings can all be interpreted as evidence of supernatural activity by observers who are primed to expect such phenomena. Cultural influences have shaped triangle mythology in ways that reflect the fears and fantasies of different eras. During the Cold War, triangle theories often involved secret military experiments or underwater bases operated by foreign powers. In the space age, explanations shifted toward extraterrestrial involvement. The computer age brought theories about electromagnetic anomalies and dimensional mathematics. Each generation has projected its own technological anxieties and possibilities onto the triangle canvas. The persistence of supernatural triangle beliefs, despite overwhelming scientific evidence to the contrary, demonstrates the power of story over statistics, of narrative over data. Humans are storytelling creatures who find meaning and comfort in tales that explain the world in terms of purpose and intention rather than random chance and natural law. The triangle provides a stage where these eternal human needs can play out against the backdrop of real geography and genuine mystery. Yet, even as we acknowledge the psychological appeal of supernatural explanations, we must recognize that they serve important functions in human culture. They provide outlets for wonder and imagination, create communities of shared belief, and offer comfort to those who find the scientific worldview cold or incomplete. The stories people tell about the triangle reveal as much about human nature as they do about the waters themselves. The evolution of triangle mythology also demonstrates the remarkable human capacity for creativity and imagination. The elaborate theories that have grown up around these waters represent genuine artistic and intellectual achievement, even when they depart from scientific reality. The ability to weave compelling narratives from fragments of fact and bolts of imagination is a distinctly human talent that has enriched cultures throughout history. Understanding the supernatural dimension of triangle mythology does not require us to dismiss or ridicule those who find meaning in these stories. Instead, it invites us to appreciate the deep human needs that such stories serve and to recognize the important role that mystery and wonder play in the human experience. The triangle's greatest gift to humanity may not be any physical phenomenon, but rather its function as a mirror that reflects our eternal longing for magic in an increasingly explained world. As we drift through these waters of imagination, we find that the supernatural triangle is as real and as powerful as the geographical one, existing not in the physical world but in the realm of human consciousness where stories have the power to shape reality. Here, in the space between what we know and what we hope, the triangle continues to serve its most important function, reminding us that wonder and mystery remain essential elements of the human experience, even in an age of satellites and scientific explanation. The realm of imagination surrounding the Bermuda Triangle stands as testament to humanity's enduring need for mystery and wonder. In a world where science has mapped the ocean floor and tracked every weather pattern, the triangle provides a sanctuary for those parts of human nature that refuse to be satisfied with purely rational explanations. Here, in the borderland between fact and fiction, the impossible remains possible, and the human spirit finds room to soar beyond the boundaries of the merely known. In the quiet offices of maritime insurance companies, where clerks have spent decades carefully recording every ship lost at sea, a different story of the Bermuda Triangle emerges. Here, in filing cabinets filled with accident reports and ledgers thick with statistical data, the romance and mystery of supernatural explanations gives way to the patient mathematics of reality. The numbers, accumulated over generations of careful record-keeping, tell a tale that is both more mundane and more reassuring than the legends that have captured popular imagination. Lloyd's of London, the venerable insurance market that has been covering maritime risks for more than 3 centuries, maintains perhaps the most comprehensive database of shipping losses anywhere in the world. In their archives, every significant vessel loss is recorded with meticulous attention to detail: the name of the ship, the date of loss, the cargo carried, the number of crew members, the weather conditions, and when possible, the cause of the accident. These records, spanning decades of global maritime activity, provide an invaluable window into the true statistical reality of ocean travel. When researchers began examining Lloyd's records specifically for losses in the Bermuda Triangle region, they discovered something that contradicted the area's fearsome reputation. The rate of vessel losses in the Triangle was not significantly higher than in other heavily traveled maritime regions around the world. In fact, when adjusted for the volume of traffic that passes through these waters, the Triangle's safety record was remarkably similar to that of comparable shipping lanes in the North Atlantic, the Mediterranean, or the approaches to major ports around the globe. The United States Coast Guard, whose responsibilities include search and rescue operations throughout the Triangle region, has maintained detailed records of every significant maritime incident in these waters since the early 20th century. Their files contain thousands of cases ranging from minor mechanical failures to major disasters, each documented with the careful attention to detail that characterizes military record-keeping. Coast Guard statisticians have analyzed these records extensively, searching for patterns that might explain the Triangle's reputation for unusual phenomena. The Coast Guard's analysis revealed that the vast majority of incidents in the Triangle could be attributed to familiar causes: human error, mechanical failure, adverse weather conditions, and the inherent risks of operating vessels in a challenging marine environment. Very few cases remained genuinely unexplained after thorough investigation, and those that did were no more mysterious than similar cases that occur in other parts of the world's oceans. One of the most significant factors affecting Triangle statistics is the sheer volume of traffic that passes through these waters on a daily basis. The region serves as a major crossroads for shipping between North America, Europe, and the Caribbean, with hundreds of commercial vessels transiting the area every day. Miami alone handles more than 9 million tons of cargo annually, while Fort Lauderdale serves as one of the world's busiest cruise ship ports. The airports of South Florida process millions of passengers each year, many flying routes that pass directly over Triangle waters. When the number of incidents is compared to the total volume of traffic, the Triangle's safety record becomes even more impressive. For every vessel or aircraft that encounters problems in these waters, thousands more complete their journeys safely and without incident. The mathematical probability of any individual voyage experiencing difficulties remains extremely small, well within the normal range of risk associated with maritime and aviation operations anywhere in the world. The phenomenon of selective reporting has significantly distorted public perception of Triangle safety statistics. Successful voyages and routine flights generate no news coverage, leaving no lasting impression in public memory. But any incident that occurs in the Triangle, no matter how mundane its cause, receives disproportionate attention because of the region's reputation. This creates a psychological bias where people remember the rare incidents while forgetting the countless safe passages. Academic researchers have conducted numerous statistical analyses of Triangle incidents, comparing loss rates with other maritime regions and examining trends over time. These studies consistently show that the Triangle's reputation for unusual danger is not supported by objective data. Dr. Larry Cushy, a research librarian who spent years investigating Triangle claims, found that many of the incidents cited in popular books about the region were either greatly exaggerated, completely fabricated, or occurred outside the Triangle boundaries altogether. The insurance industry, which has perhaps the greatest financial incentive to accurately assess maritime risks, does not treat the Triangle as a particularly dangerous region. Insurance premiums for vessels operating in triangle waters are calculated using the same risk factors applied to other areas: the type of vessel, the experience of the crew, the season of travel, and the specific route to be followed. There is no additional premium charged for triangle operations, which would certainly exist if insurance actuaries believed the region posed unusual risks. International shipping organizations maintain detailed databases of maritime casualties that allow for precise comparison between different oceanic regions. The International Maritime Organization, which oversees global shipping safety standards, publishes annual statistics that break down vessel losses by geographic region, type of vessel, and cause of incident. These statistics consistently show that the triangle falls within normal parameters for maritime safety when compared to regions with similar traffic density and weather challenges. The development of modern navigation and communication technology has dramatically improved safety statistics for triangle operations, just as it has for maritime operations worldwide. The introduction of radar, satellite navigation, improved weather forecasting, and reliable radio communication has reduced the rate of maritime accidents across all oceanic regions. The triangle has benefited from these technological improvements in exactly the same way as other parts of the world's shipping lanes. Seasonal variations in triangle incident rates follow predictable patterns that correspond directly to weather conditions and traffic volume. The highest number of incidents occurs during hurricane season, when tropical storms and severe weather create genuinely dangerous conditions for all types of vessels. The lowest incident rates occur during the winter months, when weather is generally more stable and recreational boating activity is at its minimum. The types of incidents that occur in the triangle also follow predictable patterns that mirror maritime casualty statistics from around the world. The leading causes of vessel loss are collision, grounding, fire, explosion, and severe weather damage. These are exactly the same factors that cause maritime accidents in other heavily traveled waters, with no unusual or unexplained phenomena appearing in the statistical analysis. Aviation safety statistics for triangle operations show similar patterns to maritime data. The Federal Aviation Administration maintains comprehensive records of aircraft incidents in the region, and these records show that the Triangle's aviation safety record is consistent with other high-traffic areas. The most common causes of aircraft incidents in the region are pilot error, mechanical failure, adverse weather conditions, and fuel exhaustion, the same factors that cause aviation accidents throughout the world. The apparent clustering of triangle incidents in certain time periods, which has fueled speculation about supernatural causes, actually reflects normal statistical variation combined with changes in reporting practices and traffic volume. When researchers examine long-term trends rather than focusing on specific incidents, the pattern of triangle casualties shows the same gradual improvement in safety that characterizes maritime and aviation operations worldwide. Modern satellite tracking and automated distress signaling systems have made it virtually impossible for vessels or aircraft to disappear without trace in the Triangle region. Every commercial vessel and aircraft operating in these waters carries multiple backup communication systems, GPS tracking devices, and emergency locator beacons that make their positions constantly known to rescue authorities. The era when ships and planes could simply vanish without explanation has largely ended thanks to technological advances. The economic impact of triangle operations provides another perspective on the region's actual safety record. The billions of dollars worth of cargo that passes through triangle waters annually, the millions of passengers who fly over the region, and the thousands of crew members who work in these waters represent enormous economic investments. If the triangle truly posed unusual risks, these investments would not be made, and alternative routes would be developed to avoid the region. Professional mariners and aviators whose livelihoods depend on accurate risk assessment treat triangle operations as routine parts of their work. Ship captains bid for triangle routes without hesitation, airline pilots accept assignments that cross triangle airspace, and maritime insurance companies continue to provide coverage at standard rates. The unanimous professional opinion of those who work in these waters is that the triangle poses no unusual dangers beyond those inherent in any maritime or aviation operation. The persistence of triangle mythology in the face of overwhelming statistical evidence demonstrates the power of story over data in human psychology. Numbers, no matter how carefully compiled and analyzed, lack the emotional impact of dramatic narratives about mysterious disappearances. The human mind is naturally drawn to patterns and explanations that invoke intention and purpose rather than random statistical variation. Weather bureaus and oceanographic institutions maintain extensive databases of environmental conditions in the Triangle region, and these records show that the area experiences weather patterns that are well within normal parameters for its geographic location. While the region does experience hurricanes, tropical storms, and other severe weather events, the frequency and intensity of these events is typical for the Western Atlantic and Caribbean region. The mathematical reality of triangle operations is that they represent some of the safest and most routine transportation activities in the world. Every day, hundreds of aircraft fly over triangle waters, carrying thousands of passengers safely to their destinations. Dozens of cruise ships transit the region with hundreds of thousands of passengers annually, maintaining safety records that are among the best in the maritime industry. Cargo vessels carrying everything from automobiles to grain cross triangle waters as part of the normal flow of international commerce. As we drift through these waters of statistical reality, we find that the numbers tell a story of remarkable human achievement in overcoming the challenges of ocean travel. The Triangle serves not as a realm of supernatural danger, but as evidence of humanity's success in creating safe, reliable transportation systems that operate effectively even in challenging marine environments. The true mystery of the Triangle may not be why vessels occasionally encounter problems, but why so many millions of journeys are completed safely and successfully. The language of numbers, spoken in the patient dialect of insurance claims and Coast Guard reports, reveals the Triangle to be not a supernatural anomaly, but a testament to human skill and technological progress. Here, where careful record-keeping meets mathematical analysis, we find not evidence of mysterious forces, but proof of the remarkable safety that modern transportation has achieved, even in the vast and sometimes challenging waters of the Atlantic Ocean. In the gentle pre-dawn hours, as the first rays of sunlight begin to paint the waters of the Bermuda Triangle in shades of gold and rose, a remarkable transformation takes place. The mysterious realm of legend and supernatural speculation reveals itself to be something quite different, one of the busiest and most efficiently managed transportation corridors in the modern world. Here, where ancient myths once spoke of vanishing ships and impossible phenomena, the reality of contemporary life unfolds with the quiet precision of a well-choreographed dance. The Triangle of today bears little resemblance to the mysterious waters described in the books and documentaries that built its fearsome reputation. Modern technology has transformed these once challenging waters into a realm where every vessel is tracked, every aircraft monitored, and every weather pattern predicted with remarkable accuracy. The age of ships and planes disappearing without trace has largely ended, replaced by an era of unprecedented safety and communication capability. Each morning, as the sun rises over the Atlantic, a complex network of satellite systems begins its daily routine of monitoring every significant vessel and aircraft operating within the Triangle's boundaries. The Global Positioning System, originally developed for military use but now available to every mariner and pilot, provides location information accurate to within a few feet anywhere on the Earth's surface. Ships that once navigated by stars and compass now know their exact position at every moment of their journey. Automatic identification systems aboard commercial vessels broadcast their location, course, speed, and cargo information continuously to shore-based monitoring stations and other ships in the area. This creates a real-time picture of maritime traffic that would have seemed like magic to the sailors of earlier generations. Coast Guard operators sitting in comfortable control rooms can track hundreds of vessels simultaneously, watching their progress across computer screens that display the Triangle's waters as a living map dotted with moving symbols. The cruise ship industry has transformed the Triangle into one of the world's premier vacation destinations. Every week, dozens of massive passenger vessels carrying thousands of travelers depart from ports in Miami, Fort Lauderdale, and other Florida cities, bound for the crystal-clear waters and tropical islands that lie within the Triangle's boundaries. These floating cities, some carrying more than 6,000 passengers and crew, represent marvels of modern engineering and safety technology. Modern cruise ships are equipped with redundant navigation systems, satellite communication links, advanced weather monitoring equipment, and comprehensive safety systems that make them among the safest forms of transportation ever devised. Multiple backup power systems ensure that critical equipment continues to function even in the event of main engine failure. Sophisticated fire suppression systems, emergency evacuation procedures, and round-the-clock medical facilities provide layers of safety that protect passengers and crew in every conceivable emergency situation. The aviation industry treats Triangle airspace as routine operational territory, with hundreds of flights crossing the region daily without incident or concern. Modern aircraft flying over these waters are guided by a sophisticated network of radar installations, radio beacons, and satellite navigation systems that provide pilots with constant position updates and weather information. Air traffic control centers monitor every flight, maintaining radio contact and providing guidance that ensures safe separation between aircraft. Commercial aviation in the Triangle region benefits from some of the most advanced weather forecasting and detection systems in the world. Doppler radar installations can detect and track severe weather formations hours before they pose a threat to aircraft operations. Satellite imagery provides real-time views of cloud formations, storm systems, and atmospheric conditions across the entire region. Pilots receive continuous updates about weather conditions along their planned routes, allowing them to avoid dangerous areas or modify their flight plans as necessary. The transformation of Triangle waters extends to the recreational boating community, where modern technology has made previously dangerous activities accessible to amateur sailors and weekend adventurers. GPS navigation systems that once cost thousands of dollars are now available for a few hundred, providing precise position information to anyone with a small boat or personal watercraft. Emergency locator beacons, satellite phones, and automated distress calling systems mean that recreational boaters can summon help quickly, even when they find themselves in trouble far from shore. Weather services now provide detailed forecasts and warnings specifically tailored to maritime and aviation operations in the Triangle region. The National Hurricane Center tracks tropical systems with unprecedented accuracy, providing advance warning of dangerous conditions days or even weeks before storms reach the area. Automated weather stations scattered throughout the region transmit real-time information about wind speed, wave height, barometric pressure, and visibility conditions. The commercial fishing industry operates throughout Triangle waters with a level of safety and efficiency that would have amazed earlier generations of fishermen. Modern fishing vessels are equipped with fish-finding sonar, satellite navigation, and communication systems that allow them to locate productive fishing areas quickly and safely. Emergency position indicating radio beacons ensure that fishing boats in distress can be located and rescued even in remote areas of the Triangle. Cargo shipping through the Triangle has become a massive, highly organized industry that moves billions of dollars worth of goods annually. Container ships the size of city blocks transit the region on precisely scheduled routes, their movements coordinated by sophisticated logistics systems that track every container from origin to destination. These vessels are manned by professional crews trained in the latest safety procedures and equipped with navigation and communication technology that was unimaginable just a few decades ago. The Coast Guard maintains a comprehensive search and rescue capability throughout the Triangle region, with helicopters, aircraft, and high-speed patrol boats positioned to respond quickly to emergency situations. Modern rescue operations benefit from precise position information, real-time weather data, and sophisticated coordination systems that can mobilize multiple rescue assets within minutes of receiving a distress call. The success rate of Triangle rescue operations is among the highest in the world, reflecting both improved technology and decades of experience in these waters. Environmental monitoring in the Triangle has reached levels of sophistication that provide detailed information about ocean conditions, marine life, and underwater topography. Research vessels equipped with advanced sonar systems have mapped the ocean floor in unprecedented detail, identifying underwater hazards and creating navigation charts of remarkable accuracy. Oceanographic buoys scattered throughout the region transmit continuous data about water temperature, current speed, and wave conditions. The petroleum industry operates extensive offshore drilling and production facilities in and around the Triangle region, representing billions of dollars in investment and employing thousands of workers. These operations are subject to rigorous safety standards and environmental protection measures, with emergency response capabilities that can address any conceivable accident scenario. The safety record of offshore operations in the Triangle is excellent, reflecting both strict regulatory oversight and the application of advanced safety technology. Scientific research in the Triangle continues to expand our understanding of ocean and atmospheric processes, with research vessels and aircraft regularly conducting studies of weather patterns, marine ecosystems, and geological formations. Modern research techniques have provided detailed insights into the natural phenomena that earlier generations could only observe and wonder about. Underwater vehicles explore the deepest parts of the Puerto Rico Trench, while sophisticated instruments measure everything from magnetic field variations to microscopic marine organisms. The telecommunications industry has established an extensive network of underwater cables and satellite communication links that provide reliable communication services throughout the Triangle region. Modern ships and aircraft maintain constant contact with shore-based facilities, eliminating the communication blackouts that were common in earlier eras. Internet access, cellular phone service, and satellite television are available even in the most remote parts of the Triangle, connecting travelers to the global communication network. Tourism has become one of the largest industries operating in Triangle waters, with millions of visitors annually attracted by the region's natural beauty, clear waters, and tropical climate. Dive operators, fishing charters, sailing schools, and sightseeing tours provide safe, professionally guided experiences that allow people to explore the Triangle's waters with minimal risk. The tourism industry's excellent safety record demonstrates that these waters can be enjoyed safely by people with modest experience and proper guidance. The transformation of the Triangle from mysterious danger zone to efficiently managed transportation corridor reflects broader changes in human capability and technology. The same waters that once challenged the limits of human navigation and survival skills now serve as highways for commerce, recreation, and scientific research. The mysteries that once seemed supernatural have yielded to patient investigation and technological solution. Modern environmental protection efforts ensure that the Triangle's natural beauty and marine ecosystems are preserved for future generations. Marine protected areas, fishing regulations, and pollution control measures maintain the ecological health of these waters while allowing for continued human use and enjoyment. The balance between human activity and environmental protection represents a sophisticated understanding of how to use natural resources sustainably. Emergency preparedness in the modern Triangle reflects lessons learned from decades of maritime and aviation operations. Comprehensive response plans exist for every conceivable type of emergency, from individual medical situations to major disasters affecting multiple vessels or aircraft. Training exercises regularly test the readiness of rescue organizations, ensuring that they can respond effectively to any crisis that might arise. The Triangle today stands as a testament to human ingenuity and technological progress. The waters that once represented the limits of human knowledge and capability now serve as a bridge between continents, a playground for millions of visitors, and a workplace for thousands of professionals. The transformation reflects not just advances in technology, but also improvements in training, safety procedures, and emergency response capabilities. As we sail through these modern waters, we find that the greatest mystery of today's Triangle may be how completely it has been transformed from a realm of fear and uncertainty into one of safety and predictability. The supernatural dangers of legend have been replaced by the routine challenges of managing one of the world's busiest transportation networks. Here, where GPS satellites replace ancient stars and radar screens show what was once invisible, the Triangle continues to serve humanity, not as a source of mystery, but as a gateway to the wider world. The Triangle of today invites not fear but appreciation for the remarkable achievements of modern transportation and safety technology. These waters, once shrouded in mystery and legend, now shine as an example of how human knowledge and ingenuity can transform even the most challenging environments into places of safety, productivity, and wonder. The real magic of the modern Triangle lies not in supernatural phenomena, but in the very human magic of turning the impossible into the routine, the dangerous into the safe, and the mysterious into the understood. As our gentle journey through the waters of understanding draws to a peaceful close, we find ourselves returning to where we began, yet seeing everything with new eyes. The Bermuda Triangle that emerges from our exploration is neither the supernatural realm of popular imagination nor the completely mundane stretch of ocean that skeptics might claim. Instead, it reveals itself to be something far more wonderful, a place where the natural world displays its full complexity and power, where human courage meets natural challenge, and where the patient work of science gradually illuminates mysteries that once seemed beyond comprehension. The Triangle's greatest gift to humanity may not be any single discovery or revelation, but rather the reminder that our world remains full of wonders that reward careful study and respectful observation. In these waters, we have found not evidence of alien visitation or supernatural intervention, but something equally remarkable: the intricate dance of natural forces that shape our planet's oceans and atmosphere, the gradual accumulation of human knowledge and skill that makes safe travel possible, and the eternal human capacity to transform fear into understanding through patient investigation. The stories that first drew us to these waters, tales of vanishing ships and impossible phenomena, have not been diminished by our exploration, but rather enriched. We now understand that the real dramas played out in Triangle waters are human dramas. The courage of those who venture into challenging environments, the ingenuity of those who develop new technologies to overcome natural obstacles, and the dedication of those who work to make these waters safer for all who follow. The ocean currents that flow through the Triangle carry more than just water and marine life. They carry the accumulated experience of countless generations of sailors who have learned to read the wind and waves, to respect the power of nature while finding ways to work within its constraints. The Gulf Stream that once scattered the debris of lost vessels now serves as a highway for modern commerce, its power harnessed and its behavior predicted with remarkable accuracy. The atmospheric phenomena that create the Triangle's dramatic weather patterns continue to challenge and inspire meteorologists who study the complex interactions between ocean and sky. The microbursts and rogue waves, the sudden storms and seasonal hurricanes, all represent natural processes that are increasingly well understood, even as they remain powerful enough to demand respect from anyone who ventures into their domain. The magnetic anomalies that once confused compass readings and led navigators astray have been mapped and measured, their effects predicted and compensated for by modern navigation systems. The invisible forces that move through the Earth itself are no longer mysterious but are recognized as part of the complex magnetic environment that surrounds our planet, an environment that varies from place to place but follows natural laws that can be studied and understood. The geological forces that shape the Triangle's underwater landscape continue their slow work of building mountains and carving valleys beneath the waves. The Puerto Rico Trench still plunges toward the Earth's core. The tectonic plates still grind against each other in their patient geological dance, and the seafloor still holds secrets that reward those who have the technology and dedication to explore them. The human element in Triangle operations has evolved from the trial-and-error navigation of earlier centuries to the sophisticated training and technology that characterize modern maritime and aviation operations. The same waters that once tested the limits of human endurance and skill now serve as routine workplace for thousands of professionals who have learned to operate safely in challenging marine environments. The transformation of the Triangle from danger zone to efficiently managed transportation corridor reflects broader changes in human capability and understanding. We have learned to predict weather with remarkable accuracy, to navigate with precision that would have seemed magical to earlier generations, and to communicate across vast distances as easily as talking across a room. The mysteries that once seemed supernatural have yielded to patient investigation and technological innovation. Yet in solving the Triangle's mysteries, we have not eliminated its capacity to inspire wonder and respect. The natural forces that create its complex environment remain as powerful and impressive as ever, even as we understand them better. The courage required to venture into these waters while supported by modern technology remains genuine. The beauty of tropical seas and endless skies continues to move the human spirit in ways that no amount of scientific knowledge can diminish. The Triangle serves as a reminder that mystery and understanding are not opposing forces but complementary aspects of human experience. Understanding how rogue waves form does not make them less impressive when they rear up from calm seas. Knowing the physics of hurricane formation does not diminish the awe we feel when confronting these massive atmospheric engines. Mapping the ocean floor does not make the deep waters less profound or mysterious. In the end, the Bermuda Triangle's greatest mystery may be its ability to continue fascinating us even after its secrets have been revealed. The region serves as a mirror that reflects our evolving relationship with the natural world, showing us how human knowledge and capability have grown while reminding us that we remain part of a larger natural system that is both beautiful and powerful. The waters of the Triangle continue to beckon to adventurers and scientists, to commercial operators and casual tourists, to anyone who feels the eternal human call to venture beyond familiar shores. These waters no longer represent the unknown, but rather the known but still challenging, the understood but still worthy of respect. They offer opportunities for safe exploration and adventure that would have been impossible in earlier generations. As we prepare to leave these waters of exploration and drift toward the peaceful shores of sleep, we carry with us not just knowledge but wisdom, the understanding that the natural world is far more complex and beautiful than any supernatural explanation could ever hope to be. The Triangle has taught us that reality, when examined carefully and respectfully, reveals wonders that surpass any fiction. The compass that guides us through these final moments points not toward magnetic north or true north, but toward the deeper understanding that comes from patient observation and careful thought. In following this compass, we have discovered that the Bermuda Triangle's greatest treasure is not any supernatural phenomenon, but rather the reminder that our world remains full of natural wonders that reward those who take the time to look closely and think deeply. The stars that shine above these waters are the same stars that guided ancient navigators and will guide future explorers. They remind us that while our tools and knowledge have evolved, the fundamental human drive to explore, understand, and find meaning in the natural world remains constant. The Triangle connects us not just to distant shores, but to the long chain of human experience that stretches from our earliest ancestors to generations yet unborn. As gentle waves carry us toward rest, we understand that the Bermuda Triangle will continue to serve as a teacher and inspiration for those who seek to understand the complex and beautiful world around us. Its waters will continue to challenge and reward those who approach them with respect and preparation. Its mysteries, now largely solved, have revealed even greater mysteries about the intricate workings of our planet and the remarkable human capacity to unravel nature's secrets through patient investigation. In the quiet space between waking and sleeping, between the known and the unknown, the Triangle reminds us that wonder and understanding can coexist, that mystery and knowledge can enhance rather than diminish each other. Here, where warm waters meet cool currents and ancient stories meet modern science, we find not supernatural mysteries, but natural wonders that continue to inspire and amaze all who take the time to truly see them. The Triangle's final gift is the peaceful understanding that our world, in all its complexity and beauty, remains endlessly worthy of our wonder, our respect, and our careful attention. As we drift into the calm waters of sleep, we carry with us the knowledge that mystery and understanding are not enemies but partners in the eternal human quest to know our place in the vast and wonderful universe that surrounds us.